So here's a summary of the steps to find the values of trigonometric functions when theta is unknown, but you know what quadrants it is and one of the values, right? So you can use a circle of radius r, or you can use the trig identities, and I showed you both ways. So let's look through another example. In this case, I'm going to solve by using the unit circle because that's my fave. And I'll also go through again how to use the trig identities. So I have this tan theta is square root of 3 over 3. And I have that sine of theta is less than 0. Well, because sine of theta is less than 0, that means cosine of theta also has to be less than 0 because tan is positive. So that's going to mean we are in quadrant 3, which is where both x and y are negative. So my unknown theta is over here somewhere. So let's let sine of theta is negative square root of 3, and cosine of theta is negative 3. And I know that if I have x squared plus y squared, that is my radius. So I'm going to take negative square root of 3 squared plus 3 squared equals my radius. That gives me 3 plus 9 equals r. So 12 equals r. Sorry, squared. Sorry about that. So I take the square root of both sides, and that gives me 2 square root of 3 is my radius. And our radius is always positive. So now I know sine and cosine. Let's find our other values. So tangent. Oh, I also know tangent. Wait, I don't know sine and cosine. Here's why. Because my radius isn't 1. Sine of theta, cosine of theta, this was just x over y. Sorry, y over x. Ooh, let's try this again. So I have sine of theta, which is y over r, which is negative square root of 3 over 2 square root of 3, and I multiply the square root of 3 on the top and the bottom. That gives me negative 3 over 6, which is negative 1/2. For cosine of theta, which is x over r, I have negative 3 over 2 square root of 3. Multiply the square root of 3 on the top and the bottom. I have negative 3 square root of 3 over 6, which is negative square root of 3 over 2. Tangent of theta was given to me. It's a positive square root of 3 over 3. Cosecant of theta is r over y, which is 2 square root of 3 over negative square root of 3. I multiply by this top, square root of 3's cancel. Oh, cool, that's easy. And then I get negative 2. Secant is 1 over x, which is, is r over x, which is 1 over, 2 square root of 3 over my x, which is negative 3. So I have negative 2 square root of 3 over 3. And then last I'm going to do cotangent over here because I ran out of space, because I always do, which is y over x, which is negative 3 over negative square root of 3. My negatives cancel. Multiply by the square root of 3 on the top and the bottom. So I have negative, no more negative. I have 3 square root of 3 over 3. So the answer is just the square root of 3. So that's when we find the trigonometric values using the circle method. Let's take a look at trig identities and how to solve this problem. So for example 6, now we're going to solve this using trig identities. I'm given the value of tangent and that sine of theta is less than 0. That lets me know that cosine of theta is less than 0, and we are working with the theta in quadrant 3. Using the trig identity, tangent squared of theta plus 1 equals secant squared theta, I can go ahead and solve for secant squared. remember that secant squared will also be negative because it's 1 over cosine. So I have square root of 3 over 3 squared plus 1 is my secant square root of theta. So I have 3/9 plus 1 is secant square root of theta. So I get that 12/9 is secant squared theta. And if I take the square root of the whole thing, I get that 2 square root of 3 over 3, but it has to be negative, right? Because cosine's negative. This also means, and sine's negative, so my secant's going to be less than 0, and my cosecant's going to be less than 0. But this is how they relate. So secant is negative 2 square root of 3. So now I know my tangent, my secant, that's it. I got to find the other 4. So cosine, and I'm going to circle them real quick so you see them. So we've got our tangent and our secant. I'm going to find my cosine. Well, that is actually 1 over secant theta, which is 1 over negative 2 square root of 3 over 3, which is 3 over negative 2 square root of 3 multiplied by the square root of 3 on the top and the bottom because we don't like radicals in our denominator. So I get 3 square root of 3, negative 3 square root of 3 over 6, which is negative square root of 3 over 2. And that's the same answer we got in that is the same answer that we got for when we were using the circle method. Cotangent is 1 over tangent. So I'm going to get 1 over the square root of 3 over 3, which is 3 over the square root of 3, and the square root of 3 on the top and the bottom. I'm just left with the square root of 3. So next I'm going to find my cosecant. Cosecant is 1 over sine of theta, but I don't have that yet. Okay. Rethinking. I think we have to use a different trig identity. Aha, we do. Okay. So remember that tangent of theta is sine of theta over cosine theta. And if I multiply both sides by cosine theta, I find that cosine theta times tangent of theta is sine of theta. So I can find sine of theta if I take my cosine, which was negative square root of 3 over 2, times my tangent, which is the square root of 3 over 3. So I get negative 3 over 6, which is negative 1/2, which is what we got before. Okay, so now I've got sine, cosine, secant, tangent, cotangent. All I have left is cosecant. Cosecant of theta, I switched colors, we're over here in orange. Hi. Cosecant of theta is 1 over sine of theta, which is 1 over negative 1/2, which is negative 2. And therefore, using the trig identities, we found all of the exact trigonometric values of these functions. Cool, cool. Last but not least, I want to introduce the theorem of the even-odd properties. Okay, so sine is odd, cosine is even. That means cosecant is odd and secant is even. Also tangent and cotangent, these are odd as well. Remember we called a function odd if f of negative x equaled negative f of x, right? That still holds true for sine functions. We call in trig functions, we call the function even if f of negative x equaled f of x, right? Example of an even function could be a parabola. Example of an odd function would be a cubic, some cubics, not all cubics, not all parabolas, but like, remember, more often than not. So let's solve some problems. What if I want to know the sign of negative 30? Well, because sine is odd, that's going to be negative sine of 30, which is negative sine of pi over 6. And we look on our unit circle and we say, the sine of pi over 6 is 1/2, so we get negative 1/2. If I wanted the cosine of negative pi over 3, not sure why all the numbers aren't showing up, because that's even, that's the same as cosine of pi over 3, which is 60 degrees. Cosine remembers our x value, so if I go to my unit circle, the point is 1/2 square root of 3 over 2, so that means cosine's 1/2. Cotangent of negative 5 pi over 4, that's going to be negative cotangent of 5 pi over 4. 5 pi over 4 is 225 degrees, so that means I have negative x over y, so I have negative square root, the negative of negative square root of 3 over 2 over negative 1/2. Nope, I'm messing up. I'm sorry. I'm reading the point for 7 pi square root of 6. This is the point. If you're looking at your unit circle, you'll see where I made the mistake. So we go to 5 pi over 4, which is negative square root of 2 over 2, negative square root of 2 over 2, which gives me the negative of positive 1. So my answer is negative 1. Last but not least, if I have the tangent of negative 29 pi over 4, right, we're going to pull out some factors of pi. So let me give us a little bit more room. Let's change colors. Let's give us some room. So if I have the tangent of negative 29 pi over 4, that becomes negative tangent of 29 pi over 4. Well, how many times does 4 go into 29? That's going to be 7, right? So I have negative tangent of, let's go with 24, because tan has a period of pi. Actually, tan has a period of pi, so let's take out 28 pi plus pi over 4. So that's going to be equivalent to negative tan pi over 4. Well, pi over 4 is 45 degrees. That means negative square root of 2 over 2 over the square root of 2 over 2, because tangent is y over x. So I also get an answer of negative 1. And I'm getting all of this from the unit circle, like 100%. So I did post a video on how to fill out the unit circle. It's a really good thing to at least get that first quadrant down, because then you can find all of the other points by reflection.